Okay, so good afternoon here. So we'll start the second chapter and the second topic in the second chapter, that is nothing but the threads. So as we have discussed in the earlier session, that is in this particular topic, we have to discuss the process and thread, concept of multi-threading, types of threads, and all the thread related issues. So before going to actual thread, so let us see the cooperating processes. So cooperating processes is a process that can affect or get affected by the other process while executing. So any process sharing data with other process is called the cooperating process. So meaning is that, so if, for example, if the processes, multiple number of processes running in the system, and if they want to execute successfully, if they want their complete execution, there must be cooperation between them. Without cooperation, the process cannot execute successfully, or 100% execution is not possible for the process without cooperation. Very simple example, already I have told you that, for example, in a classroom, you want to sit in a classroom on a single bench, two students are sitting, means what? They are sharing the common resource, and they are utilizing that common resource, and they are cooperating with each other. By sharing the common resource, they are cooperating with each other. So there are benefits of the cooperation is the information sharing, the competition speed up get increased, modularity and convenience. These are the benefits of the cooperating processes. And along with this thing, for example, so in operating system there are producer and consumer type of processes, there are reader and writer type of processes. Means cooperating process or the cooperation or the coordination among the process, it is highlight or it is visualized with the help of this type of processes. Means yes, there are system and user process, you know it very well, but these processes are further classified or broadly classified in a producer and consumer type of processes. Producer means what? The processes, they are go on producing the information, and the consumer process, they are consuming the information that has been produced by the producer process. So example is nothing but your printer program, it produces the character printer string, and that particular character string is given to the printer driver. So printer program is nothing but the producer process. The output of the producer process is given as input to the consumer process. Yes, suppose for example, compiler produces the assembly code of the C program. So one can say this compiler is nothing but the producer process, and the assembly code which is now generated by this particular producer process, it is now consumed by the assembler, that is called as the consumer process, right? So there must be cooperation or there must be coordination between producer and consumer type of process, because if the producer is going producing and there is no consumer, there is no cooperation between the consumer process or no coordination, then there is no use at all, right? So and consumer is trying ready to consume the process, but if there is no producer process, then also there is no use for this thing. So there must be cooperation, or one can say that there must be proper synchronization between the producer as well as the consumer type of processes. Getting this point? So just a minute. So producer are the processes, they go on producing the things, and the consumer are the processes, they are consuming the things that has been produced by the producer type of processes. Means any particular output is produced by the producer, it is consumed by the consumer process. So there are the categories like your producer, there is a printer program, there is a compiler, they are the processes, such a process in the system. They are their task is to just produce the thing, and this output is consumed by the consumer process. So if the working of these processes will become successful, if there is a proper cooperation, if there is a proper coordination between this type of processes, and there is a buffer is maintained between the producer and the consumer type of process. Buffer in the sense, it is nothing but one can say that it is just a temporary memory, or it is just a temporary one where you can the producer processes, they are producing and keeping the output in the buffer, and consumer is consuming the output from that buffer. So depending upon the capacity, it is called as, it is a bounded capacity buffer and the unbounded capacity buffer. So unbounded capacity, it is not possible practically. It is a theoretical concept. Yes, buffer has the unlimited capacity, but bounded capacity buffer, yes. So buffer is having certain capacity, limited, say for example 100 messages or 100 output it can store, and the consumer process can consume from that particular buffer itself. So getting this point. So this is the concept regarding with the cooperating processes. Now the next point what we have to discuss, it is nothing but the interprocess communication. Now it is clear that for the complete execution, for the successful execution of the process, the cooperation is essential. The basic fundamental is that for 100% execution, if the process wants its complete execution, there must be cooperation, there must be coordination between the process, because there are n number of processes they are running in the system. Okay, so that is the basic concept. Now, how this cooperation is achieved? How? So you may ask the question that, okay, yes, the cooperation is required, but how the cooperation is achieved? It is a logical one. So how the cooperation between the process is achieved? So the answer is that the process, there is an inter-process communication mechanism by which the processes, they are able to communicate, coordinate with each other. Getting this point or not? Inter-process communication is the mechanism through which the processes are able to communicate with each other. So process communicate IPC with the help of IPC with each other while running, means at the time of execution they communicate through IPC mechanism. And this IPC mechanism or inter-process communication mechanism is implemented with the help of message passing system. So what exactly is the message passing system? So message passing system is says that the processes, the both parties means sender and the receiver parties, two communicating process, they are ready to communicate with each other through this particular system. So the two functions or the two primitives are used in the message passing system. They are called as the send function and the receive function. Means send the name of the destination and the receive name of the source from where the message has been received, and the message is given here. So for communication between the process, the two important factors are there. First factor is that both the parties or both the processes, the sender and the receiver, they must able to execute the function, or they must ready to execute the send and as well as the receive function, and there must be the link established between the two parties or the two processes. That is called as the communication link. So it may be unidirectional link or it may be a bidirectional link, so that the process, these two processes, they able to communicate with each other. Getting my point or not? So the link must be established before start of the communication. If there is no link established, the process cannot communicate with each other. And there are certain properties that are assigned with that are related with the communication link. So communication link, it has some capacity. It is called as the buffer capacity. Means while the sender is sending some message to the receiver process or to the destination, that message can be, that has a link has some capacity or link has some buffer capacity, means it can store some messages in it, right? Then the size of the message is also different, means there may be variable size messages as well as there may be fixed size messages, and link may be either in one directional, it is unidirectional, or it may be in bidirectional. So you can see here, so P to Q or Q to P, the both things are possible, or there is a bidirectional link is nothing but from P to Q, and both the ways it is possible. So the type of message passing system or this message passing, this is the fundamental, right? This is the, one can say it is the theory, but practically how it is implemented, this message passing system. So it is implemented with the help of synchronization, naming, and buffering. So synchronization means what? That we'll see how the synchronization is achieved for the inter-process communication or the IPC mechanism. So it is very simple that if the two processes, sender as well as the receiver processes, they want to communicate, then there must be proper synchronization established between these two processes. So synchronization implies that blocking send, the first type is nothing but blocking send and the blocking receive, means both the sender and the receiver, they are blocked till the complete message is received. Very simple example is that a person is talking on with his phone on the mobile, right? So till the entire conversation, both the parties, they are engaged during this conversation, right? So that is the thing is that so that is called as the tight synchronization between the process. So you cannot perform other work. So when you are engaged, when you are calling to your friend, so you are saying here, hello, how are you? So there must be reply from the other side. So that is called as the blocking send and the blocking receive. The second part is that non-blocking send and blocking receive. So that in this case, sender may continue on, means sender is sending the thing, but the receiver is blocked until the requested message arrives completely. Until the requested message arrives, meaning is that sender do not have to bother. It will send the message and it will go to the other work, but the receiver must be blocked. Receiver will not move to other work till it receives the complete message. For example, your TV transmission. So in case of TV transmission, the receiver is blocked. Receiver is receiving the messages, and it will wait till it will receive the complete message that from that particular channel. but the channel is now in a non-blocking mode. The channel has just broadcasted the earlier series, and it will move to the next series, right? That is nothing but the example of non-blocking send and blocking receive. And in the third case of synchronization is nothing but the non-blocking send and non-blocking receive. Both the parties, sender as well as the receiver, they don't bother about the communication. A simple example is nothing but email communication. You just drop an email to your friend, and you go to your work, and the friend, when he check his mailbox after some time, then he receives your mail. So in both the cases, this is the case where the sender as well as the receiver, they are not blocked. They are, one can say that sending process sends the message and resumes the operation, and the receiver also receives that particular message after some time. So neither party is required to wait. The important point is that neither of the receiver and the sender, they have to wait, right? So these are the three different types of the synchronization, that is the blocking send, blocking receive, non-blocking send and blocking receive, and non-blocking send and the blocking receive here. The next type of the IPC, how the IPC is achieved, that is called as the naming or the addressing. So yes, synchronization is to achieve the interprocess communication. No doubt you require the synchronization, but for actual communication you require naming or addressing. Meaning is that the process, the sender process, explicitly mention the name of the receiver process, or the receiver process must mention the name from where it receives the message. So in case of naming, there are again two types, that is the direct communication as well as the indirect communication. So processes that want to communicate must have way to refer to each other, means they are going to refer their name, just like your postcard, means on the postcard you are putting a name on the sender, and on the reverse of that particular postcard you are putting the name from where that letter has been sent, right? So direct communication, each process that want to communicate must explicitly name the receiver and the sender of the communication. Means suppose a process P want to send the message, then in the message it must mention here send P and message, send message to process P, and receive Q message, receive the message from the process Q. Means just like your postal system, on your postcard or the letter you are putting the name of the sender, and on the reverse side you are putting the name of the on the front page you are putting the name of the receiver, and on the reverse side you are putting the name of the sender. This is the thing in case of direct communication. In case of indirect communication, what happens? The mailbox, or one can say that the indirect communication mailbox is maintained here. Means direct communication is not possible here. The process P and process Q, if they want to communicate with each other, then they have to drop the mail in the mailbox and retrieve the mail from that particular mailbox A. So here, send message A is nothing but the mailbox, and receive message from mailbox A. So that is nothing but, one can call it as the temporary storage, or mailbox is nothing but the temporary buffer, one can say, is maintained, and this mailbox can be created by the sender process, and it will be used by multiple number of processes while it is using, and it can be destroyed or it can be deleted by the process. So one can, indirect communication means what? Mailbox are used here. So messages are sent to and received from this particular mailbox, and the messages are not sent directly or to the receiver. Instead of that, it will be first placed inside the mailbox by the process, and then it will be received by the receiver process. So each mail, and one important point is that each mailbox is having his unique identification number. So a process can communicate with some other process via number of different mailboxes. So mailbox number can be, you can have multiple number of mailboxes available. So process want to communicate, they can have their different mailbox. So important point to be noted here is that here mailbox is nothing but your one type of resource, and it is called as the shared resource. Getting my point or not? It is called as the shared resource, means this particular resource is now being shared by the producer process and the consumer process, right? So how we are calling these are the cooperating processes, because here this sender process, one can refer it as the producer process. It is producing some data, and that particular data, it is now consumed by this receiver process. Getting my point or not? And this particular mailbox is nothing but actually your shared resource. Now this resource is now shared between the process, sender process, as well as the receiver process, or this particular resource is shared between the producer process and the consumer process, the buffer, right? So this is the thing, the two ways of the communication, that is the direct communication and the indirect communication for the IPC. Now the next point here is the buffering. So buffering means what? As you know that for the communication, the two processes must be there and link must be established. So the buffering is with reference to that particular link capacity, means communication link capacity. So that communication link has the zero capacity, or it may have some bounded capacity, or it may have some unbounded capacity for that particular communication link, right? So zero capacity buffer or zero capacity link, we can say that the queue has maximum length of zero, means it does not maintain any queue. So it may happen that it does not maintain any queue, meaning is that sender has to send the message at the same time the receiver has to receive it, because the message is not being stored in between the path or in between the route. Getting this point? So sender must wait until the recipient receives the message, means both the process, the sender as well as the receiver process, they must be in a tight synchronization. There must be proper perfect synchronization, because the link is not going to store the messages received from the sender, right? So in case of bounded capacity, the queue has finite length, means the communication link maintains some messages in a particular queue with some link, that is 100 messages it can store or 50 messages it can store. So at most n messages are resides in it. So if link is full, then sender must delay or wait until the space is available in the queue. So meaning is that the sender has to keep the track that whether the link is full or whether the link buffer is empty, or so there is some space. If the link buffer is full, then sender has to stop sending the message till the consumer go on consuming the messages from that particular buffer, right? And in case of unbounded capacity, it is practically not possible, but logically we can say that yes, queue has a potential infinite in length. So the sender can do not have to bother about the space or bother about the buffer capacity, and it go on producing the messages and sending the messages, right? So the buffering is the important one. So in IPC we have seen that the synchronization must be required. So synchronization has three types, that is a blocking send, blocking receive, non-blocking send, non-blocking receive, and non-blocking send and blocking receiver. Three type of synchronization. The communication must be in a two-way, either it is a direct communication and indirect communication. And third point is with reference to the link capacity. Either the communication link has the zero capacity. So what happens if the communication link is having zero capacity? What happens if the communication link is having some capacity and unbounded capacity link is there, right? So for interprocess communication, so all these points are important. So if we have, or if the for interprocess communication, all these points must be considered for the proper communication between the processes. Now the next point is nothing but the message format. So yes, the sender is sending the message, receiver is receiving the message, there must be certain fixed format for that particular message. So format is given here for a particular message. Message contains header and the body of the message. So header is nothing but the source, the destination, message length, and the control information, and the message type is maintained here. And in the body, the message contents are maintained. So this is the way how the messages are transferred, and how with the help of this message passing system, how the interprocess communication takes place in the process. So from the theoretical point of view as well as your practical point of view, this concept is very much important, because you have to implement the program for the IPC or the interprocess communication at the time of practical. Getting all of you? I think must not be any doubt. So if you have doubt, you can put me in the chat box. Now the next point that we are going to start, it is nothing but the thread. Now what is thread actually? So thread and the process. So up till now we have seen the process. So for process creation, we require the program counter, we require the process control block, right? So for that, and that process control block, it has the register set, it has the stack pointer, it has the program counter, the data code, and all the different things. So each and everything which is mentioned here, that is belonging to that particular process itself, right? So instead of creating the separate process, it will be very much easier, or it will be very beneficial, as well as it will be very much economical to create the multiple number of threads within a single process. So thread is nothing but your lightweight process. By simple way we can define it, and it is also called as the basic unit of CPU utilization. Meaning is that a thread must be exactly in a one task, or it represent the software approach to improve the performance of operating system by reducing the overhead of the process switching. So meaning is that each thread belongs to exactly one process, and no thread can exit outside the process. So remember this point. So thread is available or thread is belonging to the exactly one process. Means a single process can have multiple number of threads available. Getting this point or not? So in a single process, you can have multiple number of threads you can create. So thread is nothing but it is just a flow of work. Thread is nothing but it is similar to the process, but it is a lightweight process. And why it is lightweight process? Because it does not require what all the necessary things require for the process individually, because the threads are going to share all these things. So this particular part, so in the diagram which I have shown here, this particular part, now it is shared between all the threads, and here you can have multiple number of threads available. So threads, they do not require this independent part, just like process. Processes are independent. If we want to create a process, so for the process you have to assign separate data section, separate code section, separate counter, separate register set, and separate stack pointer. But in case of thread, the no need to provide the separate all these things, right? So one can say that, so instead of creating the multiple number of processes, it is beneficial to create the multiple number of threads and get the work done. So very simple example. So if many users, they are having their Gmail account and they are logged into their Gmail server. So for example, at the abc@gmail.com. So what happened at the server side? So the server has to create the n number of processes to handle the n number of users. So if it is so, then it will become very tedious and it will increase the load on that particular server to have the n number of processes. So instead of that, what it does there actually, so only one process, login process is maintained, and under this login process there are n number of threads are created, and each thread is assigned to each user. For example, if I am logging as a abc at the rate of gmail.com, one thread is dedicated to my particular login session. Some another user is login to that particular Gmail server, one thread is created, but the process is same. That is nothing but the login process. So for thread creation, you did not have to give so enter all this property, because this all the property is belonging to all the threads here. But if you create the separate process, then you have to assign the separate one can say things to each and every process. Getting this point? So in case of, so therefore it is efficient to have one process containing multiple number of threads. In multiprocessor, each process executes same code, but it has its own memory and file. They require their own property, or they require their own all the data set. In multi-threaded process, it uses fewer resources, including files, memory, and CPU scheduling. That is, thread minimizes the context switch time and provides concurrency within a process. So earlier, what we used to do here, we have to switch between the process. Process 1 is removed from the processor and process 2 is assigned to the processor for the execution. Means switching between the processes, it is taken place. P1 to P2, P2 to P3 and P4, and like this way. But here, the thread as it belongs to single process, so process switching is not required, or process switching is not at all required here. So that's why we are avoiding here, minimizing the context switch time between the process. And switching between the threads is there, but switching between the threads is very easier as compared to the switching between the processes. That's why threads are more economical or more beneficial as compared to the process. Getting this point? And remember one point, that process, they are having 5 states. And the same way, threads are also have the states like ready state, block state, running state, and terminated state. The same way, the processes, they are having their different state. The threads, they are having different states here, right? The thread shares CPU, and only one thread at a time is in an active execution state. Thread within process executes sequentially. Each thread has its own clock and program counter. So thread can create a child thread similar to your process. Process is able to create the child process, right? So the same way, the thread can able to create the children threads, right? The same way. So unlike processes, threads are not independent of one another. This is the important point to be noted. So processes, they are totally independent from each other. If they want to share the information, if they want to share the data, yes, there is a process communication, there is interprocess communication that we have seen earlier. But here, the threads, they are not independent. They are the part of a single process. Getting my point or not? So all threads can have access to every address in their task, right? So there is no explicit mechanism for the communication is required, like just like your process communication. So advantage, a thread can read or write over any other thread's stack, because there is no security. There is means they are having there one can say they can share all this thing, all the data as well as all the information which they require, but that is not the possible in case of our process. We need separate communication, process we need separate permission for this thing, right? That's why there are advantages of the threads, like it minimizes the context switch time. Also concurrency is maintained within the process, means within a single process multiple number of threads are being executed, so efficient communication takes place here. And as I told you that it is more economical to create and context switch between the threads as compared to the process. And it utilization of the multiprocessor architecture while using the thread instead of the process. So there are basically two types of threads, that is called as the user level thread and the kernel level thread. User level thread means they are dedicated for the user work, and kernel level thread, and they are managed at the user level, and the kernel level threads are they are dedicated for the use of operating system, and they are managed by the kernel. Getting this point? So all work of thread management is done by the application, and the kernel is not aware of existence of the thread. That is called as the user level thread. So thread library, so to perform the various operation on the thread, like create the thread, destroy the threads after its use, then passing the message and the data between the threads, and scheduling the thread execution, they require, so this all entire thing is done with the help of this thread library. And application begin with a single thread and running in that particular thread only. So from diagram it is clear that you can have user level threads, 3 to 4 user level threads, and the thread library manages all this activity. And the kernel space, there is one kernel thread that can handle multiple user level threads. And kernel level threads are nothing but the threads are totally managed by the kernel itself. Then it's supported directly by an operating system because they are kernel level threads required for the functioning of operating system. And kernel maintains context switch information about the process and the thread. The scheduling by the kernel is done on the thread basis, and the kernel performs thread creation and scheduling, and all the tasks performed by the kernel itself. So depending upon the mapping between the kernel level thread and the user level threads, so it may happen that there are multiple user level threads that are being managed by the single kernel level thread or different kernel level threads. So depending upon this management, there are three different models, and these are called as the multi-threading models, right? So how the mapping is being done means how the user level threads are managed by the different kernel level threads. So there are three different categories. The first, and it is called as the multi-threading model. This particular factor is called as the multi-threading model. So you can have many to many models. So there are many user level threads and there are many kernel level threads. So it is nothing but the 5:3 model. So 5 user level threads, they are managed by the 3 kernel level threads. So many user level threads multiplexes to kernel thread of smaller or equal numbers, and number of kernel threads may be specific to either particular application or particular model. So multiple number of kernel user level threads being managed by different level of kernel threads. Many to one model. So there are many user level thread, but there is only single kernel thread. So there are 4 user level threads that is managed by the single kernel level thread, right? The thread management is done in user space only, right? And in case of one-to-one model, so there is only one kernel, there is a individual kernel level thread is being, now it is individual kernel level thread is assigned to individual user level thread. So you can say that individual user level thread is being managed by a single kernel level thread. So one-to-one relationship between the user thread and the kernel thread, it provides more concurrency than many-to-one model. So of course there is a one dedicated kernel level threads for the each user level thread. So multiple number of threads they are being concurrently executed. So depending upon the mapping, these are the 3 important model: many to many model, many to one model, and one to one model. And this is called as the multi-threading model of the threads. The next point here is, so pthread, it is the library. It is the standard programming interface for the threads defined for Unix system, that is IEEE. So Windows not support the pthread, so you can have the pthread.h file, just like your stdio.h file include. So if you want to write the program for the thread operation, create the thread, delete the thread, then you can have the message passing between the thread. So you have to include this file. So all the operations are already defined in this .h file. So Java code is given here. Suppose if you want to create the thread in Java language, so you have to extend thread in Java, and you further write your code here, and the thread is being created. So the important difference we have to remember here is that user level thread and kernel level thread, you can have the faster to create and manage user level thread, but kernel level threads are slower to create and manage. the user level threads are implemented by the thread library, whereas the kernel level threads are implemented by the OS itself. Then the user level threads, they can run on any operating system, whereas the kernel level threads, they are specific to operating system, because the Unix, they are having their own kernel level threads. The Windows, it is having its own kernel level threads are available. Then user level thread supports provided at the user level, it is called as user level thread, the definition, and they support the threads which are being supported by the kernel and the operating system. They are called as the kernel level thread. And the next important difference that we have to remember is nothing but the process and thread. So up till now we have seen the what is the meaning of thread. So different thread operations and the thread management and the multi-threading model. So what exactly is the difference between the process and the thread? So we can say that the process is nothing but the heavyweight process. It is called as the heavyweight process, whereas that of thread is nothing but the lightweight process. The process switching needs interface with operating system. Means if you want to switch from process 1 to process 2, OS has to do this particular task. But if you want to switch between thread 1 to thread 2, that is T1 to T2, the OS is not involved in this switching, because the threads are belonging to the same single process. So within a process, thread switching is possible. OS need not have to interfere between the switching between the thread. The next important difference is that multiple processes executes same code but has its own memory. Means they are having their own memory and their own resources available, but here thread can share the same set of open files and the resources. If one user process, or if the server process is blocked, no other server process can execute until the first is unblocked. But in case of thread, it is not so. While the server thread is blocked and waiting, second thread is in a running state, or it is in an execution state. The multiple redundant processes uses more resources, whereas resource utilization is minimum, or resource utilized by multiple thread is minimum, right? And in multiple process, each process operates independently of each other. They are totally isolated, they are independent. But thread, they are not isolated, they are not independent. They can read, write each other stack, right? And basic, so process is, you can simply define as the basic unit of operating system, whereas the basic unit of CPU utilization. The thread is defined as the basic unit of CPU utilization. So these are the two important concepts you have to remember: the basically process and the thread difference, and the user level thread and the kernel level thread. So in the today's lecture, what we have seen that interprocess communication, the important point, and the thread management and the multi-threading models that we have seen today. The outcome is to understand the concept of process as well as the thread management. The questions that may be asked on the topics covered in the today's lecture is that, so write a note on interprocess communication where you have to elaborate all the things. The synchronization, first point is the synchronization, second point is nothing but the communication, direct indirect communication, and third point is nothing but your buffer capacity or the link capacity or the buffering. And the second question is that to discuss about various multi-threading models. So here you have to discuss in detail the different multi-threading model, how the user level thread are mapped with the kernel level threads, and how process and threads are different. Difference between the process and thread you have to mention here. Differentiate between user level and the kernel level thread is the next question. So these are the references. You can have the NPTEL video series also, or video lecture also, and you can see the web resources also. So thank you for this today's lecture. So we'll stop here.